Ask My Instructor 14.7.29. To evaluate the following integrals, carry out these steps. Sketch the original region and the new region. Find the limits of integration, compute the Jacobian, change the variables, and evaluate the new integral. So first, let's graph the old region. We're graphing between the line y equals 1 minus x and the line y equals negative 1/2 x, where x runs between 0 and 2. And so this is our region. We're between these two lines. They intersect at the point 2, 1, and x is running between 0 and 2. Next thing we want to do is we want to solve for u and v in terms of x and y. The first piece is easy. U equals 1/2 x. Next one isn't so bad. Solve for v. V equals y minus u. And now substitute in what we found out for u. And we have v equals y minus 1/2 x. Now we're going to find the new region. I have put up here the 3 vertices of the triangle, and what we're going to do is find the new vertices. The point 2, 1 gets moved to the point 1, 0. The point 0, 0 gets translated to the point 0, 0, so nothing moves. And then lastly, the point 0, 1 is also mapped to the point 0, 1. So again, that vertice stays where it is. And in our new region, u runs between 0 and 1, and v runs between 0 and 1 minus u. Next, we need to compute the Jacobian. So we need to find these partials, x partial u, x partial v, y partial u, y partial v. Find those partials, set up the determinant, and then evaluate. And I get a Jacobian of 2. The next step is to rewrite the integrand. Our function z equals x squared, radical x plus 2y. I want to rewrite that in terms of u and v. So I just substitute in x equals 2u and y equals v minus u, and then just do a little simplification. We're ready to put this all together to do the change of variables for a double integral. Alright, so we have our Jacobian is 2, u runs between 0 and 1, v runs between 0 and 1 minus u, and our new integrand is 4 radical 2, u squared v to the 1/2. Set up the integral. Before we try to integrate, let's simplify this integral. And we are now ready to integrate with respect to v and also evaluate. That integral is going to be fairly straightforward. V to the 1/2 becomes v to the 3/2 over 3/2, and then you're just evaluating that from 0 to 1 minus u. And this is what I get. Our next integral is much more complicated. To do this next integral, we need to do a substitution. And I recommend doing the substitution of what's inside the parentheses 1 minus u, that piece right there. If you focus on that, you'll see that's a pretty good substitution. So set w equal to 1 minus u, then dw equals negative du, and instead of u we're going to put in 1 minus w, and instead of du we're going to put in negative dw. And we rewrite our integral. So notice we have a negative out in front, and notice that our bounds are going from 1 to 0. What I like to do is I like to switch the bounds and change the sign. So when I have a negative out in front, a lot of times to simplify my integral before I do anything, I'll get rid of that negative by switching the bounds. And switching the bounds ends up being a good thing anyway. Next, I find the square of the binomial and then distribute the w to the 3/2. And when I distribute w to the 3/2, this is what I get. And our integral is now pretty straightforward. I integrate with respect to w and do the evaluation with respect to w, because remember that the bounds are in terms of w, so I never do switch back to u. And this is my final answer. Let me know if you have any questions on this.